Hey folks, welcome to another edition of AKS Me Anything. Today we're here with Charlie Lee, who is an engineering manager that looks after a few different things. You look after Windows GPUs, you look after ARM, FIPS, and you're actually running the team that looks after AKS Automatic as well. So this should be fun. So tell me a bit about what the team has been doing last week.
Last week, we working on set up the repo for the Windows GPU device plugin. Windows GPU device plugin works both for NVIDIA GPU and also AMD GPU.
So the device plugin is what you use to tell Kubernetes how many GPUs are available for scheduling, right?
Yes.
And so, we had one, but it was for Linux. So this is the device plugin for Windows.
Windows only, For now, for our Windows GPU on AKS, we only support NVIDIA GPU. And the API is only DirectX. That's something limitation to support the AMD GPU on AKS.
I see. And so with this, you will be able to support AMD GPU on Windows GPUs and have full scheduling capabilities similarly to NVIDIA as well.
Yes.
Very cool. Very good. What else the team be doing?
Yes. And also we're working on something, for example, CVM.
Okay.
Confidential virtual machine.
Very good.
So currently we just support the CVM v5 spool on Ubuntu 2004. 2004 will approach the end of life very soon, right?
Right.
So we need to extend the CVM support using new OS like Ubuntu 2404 and also Azure Linux
3.0, right, which you just launched. So that's specifically because we use different VHDs for different capabilities, so different node images for different capabilities that we provide. And so specifically for confidential VMs, we've been using Ubuntu 2004, and so now we're making the work to migrate that to 2404 and Azure Linux 3.
Azure Linux 3,
Very good. Important work. And people get that through a node image upgrade. I assume no changes
basically,
from that.
So this feature will be this CVM 2404 and Azure Linux 3 will be available by maybe June timeframe or something like that.
Very good. You hear the timeline first. Available by June. Very good. Very good. Anything else top of mind?
Manage namespace.
Ooh, interesting. Yes.
So, for example, for some class admin, right? They want to assign the whole class to different team to use.
Right.
For example, the custom admin want to say, this namespace to this team, this namespace to that team.
Right. So we have that from a lot of users, right? Like they're like, my cluster is shared by multiple teams. I have a shared cluster, maybe multiple applications, multiple teams looking after those multiple applications.
Yes.
And how? Let's start with what challenges that typically brings, right? Because that's usually hard to manage, right? When you start to be like that team that has to manage the namespaces for multiple teams, you need to think about things like presumably permissions and assignment of those. You need to manage the access to those. You need to manage the networking in and out, the quotas for all of those and things like that. And that's challenging because it often requires a full team to take care of all of that, and maybe a big team, because if you have a very complex cluster, it's a lot. So what are we doing about that?
So basically for managing namespace, the admin can assign some quota for this namespace, or one namespace for a team, right?
Right.
So for example, CPU limit, CPU request, memory limit, and memory request, those kind of stuff. So that the application of that team cannot run application beyond that limit or something like that in this namespace.
Very good.
And also we support network policy,
Okay.
then the namespace, we have some option like ingress or egress with different options like allow all, deny all,
Yeah.
or allow in the same namespace.
Very
Something
good.
like
And so that makes that work a lot simpler, because usually you'd have to go and craft all these things yourself. You had to use all the Kubernetes primitives yourself directly, and then you had to go and have to do network policies very granularly, then actually labels and all.
Yes.
And so in this case, we're just taking care of all of that. The admin just needs to use us to get that namespace going. You called it a managed namespace.
Yeah.
And then that just give that to their application teams.
Yeah.
Very
and
good.
also, we have some options when the customer, the customer meaning tries to create a managed namespace for team.
Yeah.
For those namespace, always Kubernetes namespace always exist on the cluster.
Right.
We have defined some options for the for this namespace to take over this existing Kubernetes namespace,
Yes.
or or never take over. Yeah. So for example, if you want to create a managed namespace, if the Kubernetes namespace exists, if you take never, then we just fail. We can also say, if the resource quota and the network policy is the same from the managed namespace to the Kubernetes namespace, we take it over.
That's okay.
Otherwise, we don't take over. Something
That's pretty cool. So you don't only support new namespaces into this managed namespace concept, but you can kind of adopt existing ones if they match what your definition is.
Yeah.
Very good, very good. So even if you already have, you're a team and you already are providing these namespaces today, you're already doing that work yourself, you're not barred from using this. You can just adopt those into this new concept.
Yes,
that's really good. That's really good. And you can still, I presume, use all the same things you used before. So if you have pipelines targeting namespace and all that just works still.
Yes.
Very, very cool.
Also, we have some, provide some delete policies.
Of course.
For example, if you want to delete managed namespace and want to keep the corresponding
namespace there,
Kubernetes namespace, you can say, keep.
You can keep or then delete with the deletion of the
If you want to delete both the managed namespace and Kubernetes namespace, you just delete. Choose delete.
I love when things just make sense as I hear them for the first time, so that's good. It feels to me like a very similar approach as what happens with persistent volumes and more, where you can decide to retain the underlying disks or not when the persistent volumes are deleted. So it's a very similar, I think, follows the same patterns and concepts as Kubernetes. That makes a ton of sense. And I feel like we have stuff like build coming up, so I expect some updates there from your team and more like what can we do after build on some of these things. That's very, very exciting. I'm looking forward to show that to folks and that folks get the use of it and give us feedback as well. So assuming this is going to go preview first and then very good.
Maybe we'll go public previews pretty soon. And then we will go GA maybe sometime later.
Sometime after that. That's awesome. That's great. Thanks for sharing. That's a lot of work already the team is doing. What about what would you say you're most excited about for the future?
Not all things, but one thing I didn't mention is hosted system node pool or components
of the system node pool. What do you mean by hosted? I thought we already host them.
For now. For example, when we create an AKS cluster, right? Always we need to say, create a system node pool, right? The system node pool is on the customer subscription, right? So sometimes.
Well, hopefully people know what the difference is between system and user node pool. So it might be a quick parenthesis here. So system node pool there are different modes of node pools in AKS when you create a node pool, and you can choose, as an example, system or user, or there's a third type called gateway, which is for the egress gateway feature. And the other two types, they define if a pool is meant for system components primarily or for user workloads, hence the name system end user. And those were created because they have different affinities that the components have for them. You can use specific taints in some of them, and usually need in a running cluster at least one system pool running, so it runs the system components.
Yeah.
Right, and so those today you were saying are in the user subscription.
Yeah,
and
all
so,
those things on the user customer subscription.
Right.
So according to our previous experience, right? Sometimes when we try to upgrade the system node pool, sometimes it might fail because the quota issue, the quota restriction on the customer subscription, right? Also, sometimes it fail that the system add-on upgrade will fail because customer set up some PDB, something like that. Yeah.
Right.
Yeah.
And so basically today, because this is running on nodes and node pools that the user sees, it's causing quite a number of potential issues, because at the end of the day, the user can customize, they can choose different options, and so they could run into different issues, be it or not their fault. Things like quota, they run out of quota, and that, for example, our upgrade typically does a surge node.
Yeah, surge node. Yeah.
And so if the surge node doesn't have, if the subscription doesn't have enough quota, that surge node doesn't happen, so that could fail. The other thing that you were saying was, in cases, and there's multiple of them, where maybe the availability in those system nodes can be influenced by something that the user does.
Yeah.
Right? And that could be things like setting up other components in it. We don't recommend it. We recommend that they're kind of isolated and tainted. If you check the system pool documentation, that's the best way to do it. But a lot of users in different environments use them for multiple things, which is less advisable, but of course it still works. But in those cases, essentially noisy neighbor issues essentially is what can happen, right? In all kinds of different ways, be it configurations or user applications that are occupying and maybe running those nodes very hot. It might not have into account the needs of the system components to either scale or upgrade.
Yeah.
Okay. So I get the problem. What are we thinking about how to solve it, though?
So basically, we will run the system components on AKS side. We'll not we will not run those system add-on system components on customer.
So today we already run the control plane components, things like the API server, the scheduler, the cluster autoscaler. And what you're saying is we're looking at ways and exploring ways to run things like, I guess, core DNS.
Core DNS, and also matrix server. So
things that we typically need to run in the data plane historically, we're going to find ways to run those and host those, so that all the things that we just said before would just not apply. Because it's no longer the customer quota or capacity or whatever that affects the scaling and upgrading. It's no longer the cases of noisy neighbors. And even if the user is doing everything they're right, they don't have to configure anything, right? We just configure it for them out of the box. That's really, really good. Okay, that would get me excited as well. That's really, really good.
So that's the next big stuff that we're working on in the near future.
Very good.
We're excited too.
That is really exciting stuff. I think folks are going to find that really, really interesting. They want to know more. So I presume that's going to be coming into things like AKS Automatic, of course. It will be part of the AKS Automatic. So. Very good. I suspected that, given that your team owns that. That makes a ton of sense. So thank you so much for having this chat with me and showing so many things that your team is working on and giving us updates on very exciting things coming in the near future. It was a pleasure having you. I hope you folks enjoyed another edition of AKS Me Anything. As usual, please like and subscribe to the AKS community and let us know for this series what other topics you'd like us to talk about. If there's anyone you'd like us to interview as well around, I'll try to find them around the office if I can. And have the rest of a great week. Thank you.
Thank you. Bye.